Hey everyone, my name is Nick Como. I'm a co-founder here at aiquery.io, and I'm super excited to share with you our new offering here today and then hop in the console and give you a little sneak preview. So without further ado, let's dive through these slides so we can get into the good part and show it in action. So logical starting point, what is AI query? Well, it's based on osquery. So if you're familiar with osquery, excellent. It's gonna make a ton of sense to you. If you're not, don't worry, I'll give a 10,000 foot overview, although I do highly recommend checking out the multitude of resources that exist out there, whether it's blogs, YouTube videos, or even just going to their website, downloading the binary and testing yourself on your local machine since it is free and open source. But with that said, the super high level overview is that osquery is an open source real-time query utility that was developed by Facebook roughly a decade ago with the intent of filling gaps in data that they were getting from the other tools in their environment. The way that it operates is it turns your entire fleet, your endpoints, and your servers into queryable databases under one unified common language, which in this case is SQLite. Really, what that does in the question and answer model makes it so you can harvest data in a lightweight fashion that's not reliant on resource intensive scans or polls, making the perfect complement to everything else you have within your security and IT operations stack, be it pulling additional context for the sake of an investigation or gathering broad swaths of data to help validate compliance or identify potential misconfigurations. OS query use cases are virtually boundless. Now, the only fundamental problem is that it is inherently rate limited by your own knowledge, right? So you only get good answers if you ask good questions. And the problem is that if you're not a SQLite expert, which I know I most certainly was not when I first started utilizing this tool, and I still wouldn't consider myself one today, if you don't ask the right questions, you're not getting the best answers. And that's where artificial specialized intelligence comes into play, attempting to take plain text questions and generate verbose SQLite queries against supported tables, effectively minimizing the barrier to entry, but also improving query fidelity and adding some additional complexity and refined capabilities to make it tailored to your unique environment or use cases, which we'll showcase when we get into the tool. And then the last piece, which I know my head's covering a little bit, is some functional enhancements. You can kind of think of these as more enterprise grade features, really trying to enhance the raw capabilities of OS query and get the most out of it. So maybe some things you're familiar with, like query packs and schedules, or maybe something else like a REST API, so that it can act as that force multiplier to everything else in your environment, whether it's dumping the data to a SIM or ticketing system, or using SOAR orchestration to automate query running based on XYZ signal from something else in your security stack. Or the last piece here, live shell, which allows for precise surgical remediative actions based on the data that you're gathering remotely to any device. So with all of that said, again, we're going to show it in action, but all of that ultimately culminates in AI query, where really our focal point here is to try and capitalize and expand on the already powerful capabilities of OS query and make them more accessible to everybody. So hopefully we can showcase that when we pop in the console. But yeah, that's the high level, and I'll check you over in the product. So see you soon. All right, now here we are within the console. As you can see, we're on the Create New Query page. I'd love to go through the other capabilities, but unfortunately, we do not have time. This is just a brief snippet video. If you are interested, please check out our website, aiquery.io. Feel free to book a demo. I'll answer all your questions and show off everything we have to offer. But for today, we're just going to go through one very basic example. Say we got a ping from our network admin saying that there was some unusual attempts at login or odd behavior coming from an unknown IP address on one of our critical application servers, which in this case we will then select. That is our EC2 WinServe instance. And so we're going to want to start with just corroborating this information, potentially looking for attempts at logins on that device. I can check out view schema, but I already know that I want to use the Windows event log table because all attempts at login, failed, or successful are within the Windows event log. If you are not familiar with this table, it is an incredibly powerful table. It basically allows you to extract information directly from Windows event log utilizing OS query in JSON format. Super valuable, little complex to use though, because you have two conditional clauses that are required with the channel and the event ID, and then really what you're looking for is housed within this data field, which is going to return a JSON blob that you need to effectively extract. So a little bit outside the scope of my capabilities in query writing aptitude, but that's where luckily AI comes in. It's not lucky, I set it up that way. So we'll click Use AI and it'll open this right-hand panel, which we call QuerySmith. So you can build your query. And the first thing we'll want to do is select the mode. I'll circle back to mode, but in this case, we'll use Windows Event Log, do failed user logins, and hit generate. So circling back to mode. So what exactly is mode? Basically, we want to not have AI be too broad, but then also have specific use cases that it was more adeptly trained for. So for something like a very complex table, like the Windows event log, we have a set mode for that. Or if you wanted to look up a specific MITRE TID or generate a YAR signature, you could do that. However, if you're not certain and it doesn't directly fall into your set use case, just use general. It's really the catch-all. And then regardless, you can always refine after the fact, which is exactly what we'll talk about right now. But first, let's look at what was generated for us right here. We can click on that node, and then if we expand this down, we can see that we have the prompt of failed user logins. We can see the SQL that was generated for us, a description, and the supported operating system, which, to no one's surprise, is Windows. But if we look a little bit deeper into the actual query that was generated for us, we can see that specifies the event ID of 4625, which is great. I would have had to do research and look that up. The channel being security. And then here we can see the JSON extract function over the data field, and then even specifying what exactly we're attempting to extract. So not only is this helpful from the complexity of the query, but the fact that I would have had to do some research to figure out exactly what I'm trying to extract as a result, but instead AI does the research for you, crafts the query, and then sets these up as case statements so that it's just easy to read and extract that information. Now, the only thing I'm missing here is I do not see IP address, which will be helpful in correlating and corroborating the information that I got from my network admin. So let's go ahead and say add in IP address and hit refine. So while query generation is super valuable and a great helpful starting point, I think really refine is where it shines because you get a good baseline, but then tweak and tune it to your specific use case, your specific scenario, your environmental needs, and that's really where you get the best fidelity query out of it. And that's what we can see right here. We just asked it to add IP address and it knew exactly what to extract right here. So now IP address is there. So this is almost perfect. The last thing we want to do is narrow down the scope so we're not just getting all failed logins. And let's say over the past, 12 hours, because that's when we got notified they started seeing abnormal activity on that device. Granted, we'd probably actually want to broaden the scope to see if anything happened earlier that we may not have caught, but just, again, we're corroborating here. So perfect, we can see the changes added. We added the conditional clause of the date time. And what we will want to do now is hit accept, which will populate it on over here. Give it a title, say failed logins past 12 hours, and then execute on that device. So we could continue working, generate a couple additional queries, try and add more context. But again, for the sake of just this quick demo, we're going to pivot on over to the results page. Here on the results page, we can see each of the queries that have been run, when they were initiated on, how many devices, who initiated it. And then here, if we hover, we can see the progress bar. Very helpful when you're querying a bunch of devices to see the set progress of which ones have returned and which haven't. Obviously, in this case, we're just querying one-to-one. But here we can see the response and the devices. Again, just one-to-one, but if you had a bunch of app servers or something like that, you could see which ones have responded, which ones haven't yet. And then here we can see the information of the IP address, the username, and when the event took place. This is excellent. However, we have 84 pages of 20 results apiece. Makes it a little bit difficult to sift through. So that's where we'll utilize filtering because data without context is effectively useless. And oftentimes in an investigation, you may not know exactly what you're looking for, but you know what you're not looking for, if that makes sense. You know what normal is in your environment. So let's filter out a normal IP address. So here we have this 3 dot, and we'll put that in here, and we'll apply that filter. That removed a good chunk, but we also see the username of administrator coming up a bunch, and we can just filter that out as well. So we'll do add filter, username not contains, just to be lazy, and say admin, and then hit apply. And that's perfect. Now we've whittled it down to not known IP addresses and not known users, and we're seeing a bunch of this verbal kint, which is very suspicious. If anybody's seen The Usual Suspects, you know that verbal kint and Kaiser Sose. But anyway, we've corroborated the information. We've whittled down the results from 90 pages of results to 6. And now we have definitive proof of an odd attempt at login. We have the set IP address to correlate back to our network team. And we've answered one question. That's opened up the door for about 5 additional questions that we need to answer, but that's in a later video. I just want to show kind of the brief overview of how you can take a piece of information, delve in, add additional surrounding context, filter down your data, and then get a reasonable result. So that's the highest of high levels. Much more to showcase. Again, please, if you're interested, check out our website, aiquery.io, and feel free to book a demo. And until next time, thanks.